Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farauni binti Muhammad Kamaru Hasmadi, and I will present from the poster about the application of eigenvector, which is derivation of special relativity. Alright, so first of all, I will start with the definition of all related with relativity. So we included relativity, special relativity, the first and the second postulate of Einstein's special relativity. So the first one is relativity, the study of how different observers measure the same event. And the next one is special relativity, the theory which in initial frame of reference, the motion of an object is relative to the frame from which it's viewed or measured. So in easy word is the action of I am observing the moving train. So that is a special relativity. I'm walking and I observe the moving train. Okay, next, moving on. Moving on to first postulate of special relativity, an idea which laws of physics are the same and can be stated in their simplest form in all initial frames of reference. And the second postulate of special relativity, which included in the poster before this, which is the idea that the speed of light is a constant independent of the source, speed of source, which is the sun. Alright, moving on, I will explain the detail for the second postulate of special relativity. Okay, as I mentioned before, the second postulate is the idea that speed of light is constant independent of the relative motion of the source, which is the sun. So the Michelson-Morley experiment demonstrated that the speed of light in a vacuum is independent of the motion of the earth about the sun. Alright. Okay, next I will mention about the misconception. People misconception about the speed of light. Okay, speed of light, which is 3.8 times 10 power of meter per second. However, in law of refraction, the speed of light in matter is lower due to the index of refraction. So the correction one is special relativity applies only to unaccelerated motion, but general relativity applies to accelerated motion. So between the lights and the sun, there are no acceleration motion. So that's what it means. Okay, continue for the second postulate. As I read on from the information, it said that second postulate is the consequences from the first postulate, because of if Maxwell's equation holds in all inertial frames, then only possible value of the speed of light is c, which is 3.8 times 10 meter per second. So the first postulate and the second postulate, these postulates embody Einstein's special theory of relativity, which is what we learn right nowadays. So, okay, for the general theory of relativity, as in Newtonian relativity, there is no way to detect absolute motion, only the relative velocities between two inertial reference frames matter. This is also means that from the second postulate, okay, and the first postulate. So, for example, when you turn on the headlights of a car, the light beams lift the car at a relative velocity of c, which is 3.8 times 10 power, 3.8 times, which is which is 3.8 times 10 power of 8 meters per second. However, someone standing on the sidewalk also measures the speed of the light beam as c independent of the velocity of the car. So right here we can see the second postulate happening here. So this is all the detailed information about the second postulate. Okay, for this derivation of special relativity, this is where the eigenvector used, which is in the Lorentz transformation. Okay, so look at this. For example, I have that matrices, and the vectors are where at C and negative C, V and negative V, and also t. So we have the vectors and the expansion of the vectors as stated there. Alright, so the next step is to convert metric equation to the linear equation, and then we solve the equation to find out the a1, a2, b1 and b2. And the next one, we got the matrices solution, which included all the answers of the equations. And then state that it can verify that the two vectors corresponding to the word lines of flight are indeed the eigenvectors with the following eigenvalues, which are lambda 1 and also lambda 2. And then the last step is when we there are few steps over there, but I'm not explaining in detail because this is Lorentz transformation that we have learned before this. So this is where the eigenvectors and eigenvalues is used in this application. Alright, so the last one, actually this is a bit of additional information for the first postulate of special relativity, as I did not include it into the poster, as I already mentioned about the second postulate of special relativity. So here is the graph that I found from the internet. So actually this information already spread out on the internet, so I just want to let it know here. So okay, so this is the graph. Okay, so what is this about? So imagine we are viewing a cat at moving speed from our perspective, and we want to know what the world looks like from the cat's perspective. So this is the space-time diagram. So for the eyesight from the cat as the green one, and eyesight from us is the moving along the time axis, which is this one, and the word of lights, the word lines for lights are the purple one and the red one. So here we can see that we needed the eigenvectors and eigenvalue to derive the formula or to calculate something, because the graph looks like this and here. So we needed that values to find out any information that we want from this situation. Alright, so that's all from me. Thank you.